Good morning one and all, welcome to my channel Miracles of Math. So in the previous lectures we learned what are sets, what are the different representations in that is roster form and set builder form, and in the next lecture we also learned what are the different types of sets, finite sets, infinite sets, equal sets, equivalent sets, okay, and empty set and singleton sets. And in today's class, we will move forward to one more topic, that is subsets. Okay, so today we will learn what are subsets and supersets. In the same subset, we will also see supersets and power sets and power set. What is a subset? What is a subset? So let us take one example and see what is subset. Let us take A is equal to 1, 2, 3. So now what I want to write? I want to write all the terms such that I am selecting only one from here. Only one element from here, not the element 1. Only one element, or only two elements, or all the three elements, or no element. Or no element, that means 0 elements. So I want to write all the possible ways of selecting items from this set. Simply think like this. You have a box of chocolates. 1, 2, 3. 3 kinds of chocolates. So someone gave you the box and asked you to take any chocolate. Take any number of chocolates you want. You can take 0 chocolates. That means not selecting any chocolate. You can select 1 at a time. You can select 2 at a time, and or you can take all the 3 at a time. Understood? So the list of all these are called subsets. The list of all these are called subsets. So I'll take that subset as B. So B is equal to selecting only the first element, and that should be written inside brackets, or selecting only number 2, only second chocolate, selecting 3, or selecting 2 chocolates at a time, 1 and 2. You're taking both chocolates at the same time. So you can take 1 and 2. And you can take 2 and 3, or you may also take 1 and 3. You may also take 1 and 3. You may take all the 3 if you want. All the 3, 1, 2, 3. And one more case is left where you're not choosing anything. You're not taking any chocolate. That means simply empty brackets. Empty brackets. Or what is this empty brackets? That is called empty set, which we represent with 5. Yes or no? So all these are subsets of A. All these are subsets of A. So you can say like this: B, whatever it is, just if you take 1 or 2 or 3, let us say 1, 2. 1, 2 is a subset of, subset we represent with this one, subset of A. A means 1, 2, 3. All these are subsets of the given set A. I can also write like this 1, 2, 3. 1, 2, 3 is a subset of the same 1, 2, 3. Okay, as these two are equal, we also keep an equality here in this way. Okay, so this is the actual symbol for subset. When I'm talking all the subsets, we represent with this format, in this way. Okay, all these are subsets of A. We will take one more example. See, the very major mistake you do is you will not consider this and this one. You will forget to write this, and you think that you have listed all the possible opportunities. We will take one more example. How many elements are there? Can you tell me? There are 3 elements here. 1, 2, 3, 4, 5, 6, 7, 8 elements are here. There are 3 elements here, there are 8 elements here. Just remind this one, I will again ask you later. Let us take one more example. Now what we'll do, we'll take 4 elements. Okay, we'll take 4 elements, like set A is equal to, let us say 1, 2, 3, 4. I want to write all the subsets. See, it's very difficult. As we increase the numbers, it will be difficult to write all the possible opportunities or options, so we'll try to write properly. So selecting 0 at a time from here. So that means an empty set which is 5. Setting 0 elements from here. Selecting only one element, that is, you can select 1 or 2 or 3 or 4. Selecting only one element at a time. You have 4 chocolates and you're taking no chocolates, or 1 chocolate, or you can take 2 chocolates at a time. That is, what are the available options of taking 2 at a time? 1, 2. You can take first chocolate and second chocolate, or 1, 3, 1, 4, or you can go for 2, 1. 1, 2 and 2, 1. Are these two same or different? You are taking first chocolate, second chocolate, or second chocolate, first chocolate. These two are same. Inside the sets, if the elements are common, then those two sets are same. So no need to write this again. No need to write this again. Understood that point? Okay. So 1, 2, 1, 3, 1, 4. Then 2, 1. No need to write as we already have 1, 2. So 2, 2. Can you have 2, 2? What is the meaning of 2, 2? You're taking second chocolate, and again you can take second chocolate. You cannot do that. Okay. So 2, 2 will not come. So 2, 3, 2, 4. Anything else? 3, 4. 3, 4. You can ask me, sir, where is 3, 1? Yes, 3, 1 is here. Where is 3, 2? 3, 2 is here. 3, 3? Not possible. You don't have 2 chocolates of the same kind. That like you cannot take the third chocolate, and again you cannot take the third chocolate. So 2, 3, 2, 4. 3, 1 it is there. 3, 2 it is there. 3, 3 is not possible, and 3, 4 is here. 4, 1 it is there here. 4, 2 it is here. 4, 3 here, and 4, 4 you cannot take. So these are the options taking 2 at a time. What about 3 at a time? Let us see that. Take 1, 2, 3 chocolates, third chocolate, or 1, 3, 4, first, third, fourth, or select 2, 3, 4. Anything else possible? 2, 3, 4. Anything else? 3, 2, 1. It is there here. 3, 1, 2. It is there here. 3, 4, 1. It is there here. 3, 4, 2. It is there. 4, 2, 1. 4, 2, 1. 4, 2, 1. Yes, that is missing. 1, 2, 4. We haven't written 1, 2, 4. See, we got one more. That is 1, 2, 4. 1, 2, 4 or 4, 2, 1 or 2, 4, 1. All are included in this one. And so taking 3 at a time are done. So now the last case is taking all 4 at a time. That is 1, 2, 3, 4. 1, 2, 3, 4. So total how many subsets are possible? All these are subsets. How many subsets are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 4 elements here and we are getting 16. What is the before thing I would set you to remember? We have 3 numbers in the 3 elements and you got 8. So any relation between the number of elements and the number of subsets? Yes. So we are not going to prove that, but the formula behind that actually comes from binomial theorem, which we are not discussing now. In binomial theorem, we have a formula like from n objects, selecting one object, Nc0. You will learn this one in binomial theorem, or maybe when you're learning permutations and combinations, or maybe in the probability. Okay, so assuming that you know this one, even though you don't know, just don't worry. You just remember what is the final formula. That is only important here. From n objects selecting 0 objects, or from n objects selecting 1 objects, plus selecting 2 objects, plus so on, from n selecting all the n. That is the same what we have written just now. All the subsets. Taking 0 at the same time means it is an empty set. Taking only 1 at a time, taking 2 at a time, taking 3 at a time, taking all 4 at a time. That is for example. So in binomial theorem, this has the formula as 1 plus 1 whole power n. 1 plus 1 whole power n. That is, it is 2 power n. It is simply 2 power n. This formula is 2 power n. So carefully observe. If there are 3 elements, the number of subsets are 2 cube, 2 power n. There are 4 elements, number of subsets are 2 power 4, that is 16. If there are 5 elements, 2 power 5, 32. There are 1 element, we will see when there is only 1 element. one element or no elements, we'll see what happens. The formula remains the same. The formula remains the same, that is 2 power n. The formula is 2 power n. When you have only one element, let us say the set is having only the element 5. So as per the formula, 2 power 1 which should give you number of subsets as 2. Which should give you number of subsets as 2. So what are the number of subsets here? See, selecting 0 at a time or selecting all the elements, that is 1 at a time. So how many subsets are possible? We have 2 subsets. Always you need to include this empty set also in its subsets. Okay, what about if we just have no elements? What is the meaning of no elements? A is equal to just 5. That means just the empty bracket. How many elements are there here? 0. N equal to 0. So what is 2 power n? It is 2 power 0. That is 1. What is that one number of subset? It is the same set itself. I told you, even the same set will be a subset of itself. That is one property actually. Every set is a subset of itself. There are 3 chocolates. Taking all 3 chocolates is also one selection. So from A, taking all A is also one subset. Every set is a subset of itself. And 5 is a subset of every set. 5 is a subset of every set. Subset of every set. Understood? So here the set is 5. The set A is 5. What are the subsets involved in that? Just the element 5 is itself the same subset. Every set is a subset of itself. So the same 5 will be subset of itself. Clear? So this is about subset. And I told you in the starting, we will also see what is superset. What is a superset? When A is a subset of B, let us say, that means B will be a larger set 1, 2, 3 and A will be a smaller set, let us say 1. As 1 is a part of B, we say A is a subset of B. A is a subset of B. Okay. When A is a subset of B, we say B is the superior. B is the parent. Okay, B is the superior. So we say B is superset. B is superset of A. When A is subset of B, we say B is a superset of A. That's it. No much complications involved in this one. When A is a subset of B, we say B is a superset of A. Clear? So the next one is power set. Before that, we'll see one more example in subsets. Let us take a set A as the element 5, set of 5, set of 5 comma set of 5. See, I will confuse you here. Carefully listen. Carefully listen. Set A has 3 elements. 1, 2, 3. Wait, I didn't mention you the brackets properly. Set A has 3 elements. 1, 2 and this complete thing is 1, that is 3. So how many subsets should be possible? For 3, 2 cube, that is 8. So we should have total 8 subsets. I will confuse you like anything if you are not listening properly. Just pay attention here. All the subsets of A. Okay, let us mention that with B. See here. As you will be confused here, just write this as A, this as B, this as this complete thing as C. Now, the first and foremost include empty set. It is not this one. It is just an empty set. That means we are not selecting anything. What is the meaning of this one? It is having 3 elements. One element itself is 5. It is not an empty set. Element itself is 5 and element of like set of 5 is 1 element and this complete set is 1 element in that. Are you understanding the difference? So first and foremost, wherever you take, empty set is a subset of itself. Empty set is a subset of every set. Now, only set A, you will be writing only set A, right? That is one subset. only set A you will be writing. Okay, I'm listing all the subsets. Phi only set A, that is only set phi, only set phi, only set B, only set B. So what is set B? B is this complete thing, students. You need to write along with the brackets in place of B. So B will be replaced with phi. Selecting only C means this complete thing. Okay, set of this complete thing, set of C, you write like this, right? C is subset. So in place of C, you need to write all this. Carefully observe the brackets, don't forget any bracket. Phi comma set phi. This complete set C came here. Selecting A and B together. So what is that? Selecting inside the set, write A and B. What is the meaning? How we can write this one? Write set A, that is phi, comma set B. Set B means this complete term. It is B. Writing A and C. A and C. How will you write that one? A means phi. A means phi. Okay, and C means this complete term including its brackets. Including its brackets. So I am writing this part here. So that is set of phi comma set phi. Okay, this is A comma B, A comma C, and now you can also write B comma C. You can also write B comma C. How you can write B comma C? B is this complete element, that is set of phi, and C is this complete element, that is set of phi comma set phi. Don't confuse with this one. This is closing to this one is closing this one, and this is closing the complete subset. AB, AC, BC. Now ABC, that means the complete set. I am not writing it again, just write it. The complete set here. So now count how many you got. 1, 2, 3, 4, 5. I'll mention here. 5 is this one. 6 is this one. 7 is this one. And 8 is the set A itself. 1, 2, 3, 4, 5, 6, 7, 8. That is the same 8 which we are talking about. A beautiful example. Don't confuse, understand. If you are having any doubt, write this complete thing as A, complete thing as B, complete thing as C, and you follow as I said. Now, quickly let us come to see what is power set. What is power set? Let us take one small example. I will not confuse with these larger examples, bigger examples. Let us take set A as 1, 2. So list out all the subsets. Phi, set 1, set 2, and set of 1, 2. If there are 2 elements, we get 4 subsets. When you write the complete thing as one more set, so I am mentioning one new set C, which is consisting of all the subsets. A set consisting of all the subsets of a given set is called power set. See, when only subsets are asked, so you shouldn't keep these brackets. That's the reason before, if you remember, I erased the bracket somewhere. When only subsets are asked, you shouldn't keep these outer brackets. When you're keeping this outer brackets, that means it is the set of all subsets. It is set of all subsets, which is nothing but power set. Which is nothing but power set. Set of all subsets is called power set. If the set A has n elements, how many elements does the power set has? How many elements does power set has? How many elements? 1, 2, 3, 4. So 4 elements are available in power set. Power set is represented with P of A. Power set is represented with P of A. So P of A or n of P of A, that means the number of elements in power set A will be 2 power n. if the set A has n elements, if the set A has n elements, number of elements in A is n, number of elements in its power set is 2 power n. Or you don't confuse with this n with n. Let us consider the number of elements as m. So the total number of elements in its power set will be 2 power m. Is 2 power m. Okay. See, I will give you one more example in the same way. As set A is having 2 elements, what are the number of subsets? How many number of subsets? Number of subsets is, as we are having 2 here, let us take 3. As we have 3 here, so it is 2 cube, it is 8. Number of elements in power set. Number of elements in power set. How many elements? All the subsets are the elements in that. So how many elements? We have 8. So the same 8 elements will come. Number of subsets of power set of given set A. See here what I am saying. Number of subsets is actually 2 power m. But how many elements are there? The elements are now power set of A. How many elements are there in power set A? 8. In power set 8. So for that 8, how many subsets are possible? 2 power n, that is 2 power 8. See, you just have 3 elements, but you have 2 power 8 number of subsets for the power set of that one. Are you understanding this one? It's very easy. List out stepwise. A has 3. Number of subsets are 8. So power set will have 8 elements. Number of subsets in that power set is, as we have 8 elements, it is 2 power 8. I hope you understood what are subsets, power sets, and superset. And one thing I want to mention you here, as we came to end telling about the sets, what is universal set? Universal set. People, we have always, when we write, let us say A equal to 1, 2, let us say 3. I am saying A is a set of all natural numbers less than 4. What is the main parent set that we are considering, from where we are bringing all these numbers? That is called the universal set. So universal set means it is the parent set for all the sets. It is a parent set for all the given set. So universal set for this one you can consider as 1, 2, 3, so on till infinity, let us say. Or you can stop at 10, 20, whatever you wish. But whatever we require the functions, whatever we require the sets, should be a part of the universal set. 1, 2, 3 are universal set. Universal set is not unique. You can define anything. You can just stop at 10. You can say that is a universal set for this one. The only criteria is all these elements should be listed in its universal set. Alright. So this is about different types of sets. So I hope you understood what are power sets, what are superset, what are subsets, and what is the final universal set. So in the next lecture we will see what or how to write intervals. Intervals, that means, say if you have numbers from 1 to 2, all the numbers in between 1 and 2 should also be considered. 1.1, 1.2, 1.0, 1.01, 1.0001. All these numbers should be clubbed. Okay, so those are intervals. How to write the intervals we will see in the next lecture. Thank you so much.